the sum of the enthalpy change for the bonds formed. I've got 4 CHs. Okay, so I'm going to look over at my table here, and that is because of this bond energy. Really cool. To use bond energies, for a reaction, we're going to use the summation. That means add up the energy, the enthalpy change for all the bonds broken, and then subtract the sum of the enthalpy change for the bonds formed. So I have an example here for you of methane. We're burning methane, making water and CO2. So what are the bonds broken? So look at my Lewis diagram here. I've got 1, 2, 3, 4 CH bonds. Okay, so my enthalpy for the reaction is going to be, let's add up my bonds broken. I've got 4 CHs. Okay, so I'm going to look over at my table here. Each one is 413. All right, and then I'm going to add the oxygen. I'm going to break 1, 2, O double bond O, because remember, oxygen is double bonded to itself. So I've got 2 of those. Each one is 498. All right, so that is all the bonds I need to break. Now let's subtract the bonds that we form. So minus, in water, I'm going to form 1, 2, 3, 4 of these OH bonds. So 4 times 463, plus in CO2, I've got 2 C double bond O's, and that is this one right here. That's a strong one. Okay, so again, I've just got to do some careful arithmetic and add all these up, and the calculator gives me a nice negative 690 kilojoules. Now, that's the heat for this reaction. Now, does that make sense? It's very exothermic. Sure, when you burn methane, you're going to get a lot of energy released, and that is because of this bond energy. Really cool.